We're going to move on to lichens and pollards again with Bjorn Norden from Norway. So not a small journey across today. Bjorn is a senior research scientist in the Norwegian Institute of Natural Research, a forest ecologist and a conservation scientist with special interest in temperate deciduous forest biodiversity were the two main areas of his research. So I'll hand straight over to you, Bjorn.
Sorry. So now I hope you hear me now. So I will also mention some things about follow-up study and about the threats, various threats to the old ancient trees in Norway. So I will start by addressing the issue of repollarding. So the trees in Norway has not been pollarded for much more, in most cases much more than 50 years, maybe on average 75 years or so in many places. And there are systems for paying people to do repollarding. And there are, of course, various ideas behind this. It's the idea of traditional management, aesthetics, and then there's the big question that I'm mostly interested in: is it better for associated biodiversity and better for the trees to repollard them or leave them? And first, I want to mention about the population of ancient trees, pollarded trees in Norway. Based on my best guesstimates, we have like 50,000 elm trees, and that was prior to the disease outbreak, and 40,000 ash trees and 20,000 linden trees and ancient trees, and all over 40 centimeters in diameter at breast height. And we have some maple trees, and the great majority of these big trees have been pollarded a long time ago, okay? And then we have also about 75,000 large oak trees, but few of them have been pollarded before. And we do have beech, but it's a recent species more or less in Norway, so it's only in the south part. So we don't have pollarded beech trees. And some of the trees are found in the infields, and used to be so more earlier, but nowadays most of them we find in the outfields, outlying lands, and that's mainly on very steep slopes. So it often looks like this, and you wonder sometimes, how did these people do in the 1800s to get those branches down? But you never cease to be amazed. They found most of the trees even at the highest slopes. So this is just to show that the infields, there used to be a lot of pollarded trees there, but now the infields have been much changed, of course, during time. But on the fields on the outlying lands, we still have a lot of them left. So that's nice. And actually, I want to promote the population of big elm trees in Norway, because this must be one of the biggest populations in Europe remaining. Still, because in this map you can see where they are, all around the coast, and also a bit inland, and even up to Trøndelag. You maybe know the Trondheim, the city of Trondheim, or even up there. We have a lot of big elm trees, and they are still not affected much by the Dutch elm disease, probably thanks to the rainy climate. So the beetles are not there, or they are not so common there, and they don't spread the disease as much. But now we are seeing in the right panel, you can see some, shows the distribution of the Dutch elm disease. So you can see there are some blue dots on the west coast also around Bergen. So it might be that it's starting to spread more there, but so far, so good. And the remaining elm trees are really a fantastic big population and have lots of biodiversity. So I think we should appreciate that more on the European level, but I've kind of failed to tell that to Europe. So nothing much is happening, but we should appreciate that a lot more. And what I'm going to tell you about the study is that we studied these sites, 66 sites, and we compared non-pollarded trees with pollarded trees. So we only chose the biggest trees we could find. They were all over 40 centimeters in diameter at breast height, but usually or often much larger. And the dots here are of different sizes. They just show the number of nationally red-listed species at each site in proportion to the size of the dots. And what we did was that we surveyed trunks up to 2 meters and looked, we determined all the lichens, bryophytes, wood and bark-living fungi, and also bryophytic fungi. And then, so we had 680 trees, and they are divided to mainly pollarded, mainly elms, and 200 elms and 140 ash trees. And divided into pollarded and non-pollarded. So we looked at the pollarded trees at each site, and then we walked around each site to find the biggest possible non-pollarded trees. They were usually hidden up in high above the scree, and very difficult to find, but we did a lot of walking in the scree. And then we recorded 452 species of epiphytes and fungi. 200 of them were lichens. And on average, we found about 17 or 18 species per tree. And then, I will come back to that, but we didn't make many observations of collapsed pollards. We checked the vitality of the trees. We checked how different environmental variables, but we didn't find a lot of evidence for collapsed pollards. I will discuss that a little bit later. So this is how they look often. So this is a nice pollarded tree, and I don't know if you prefer this look to this look. This is an elm tree that has not been pollarded and has a lot of curved branches. But I also find this quite beautiful, I must say. And yeah, as I said, only the big trees were surveyed. And this is a non-pollarded ulmus. But you can see one thing. You can see on the upper face of the tree trunk that it has been battered by falling stones during the year. So during the years it's been standing there. So actually, this is kind of a natural veteranization process going on a lot there. So when you're there, you should wear a helmet. I mean, but you often hear, when you walk in this, you often hear mumbling sound in the distance, hopefully, but sometimes the stones come. But sometimes the stones come very close to you and you need to kind of hide. It can look like this. So you see this tree here, it is a pollard tree, but it has also been battered a lot by the big stones falling, the boulders falling on it. So that's kind of scary sometimes. So then we looked for lichens, fungi, and bryophytes on the trees, and many species in this area are on the, many sites are on the west coast of Norway when it's oceanic, and so we found a lot of oceanic lichens, like Leptogium, Digelia, Planaria, things like that. But those are maybe you're familiar with from the British Isles, but we also found some species that are not present on the British Isles. I think Sclerophora amabilis is not here, and Collemma leptalium, just a few examples. And then we found bryophytes like Pterygonium and many other things, and fungi like this blue one, Tirana. But one group of fungi that we also studied was, like I mentioned, the bark-living things. Living on, they tend to sit on the living bark, and it's a very rich community that is not much known before, but I'm especially interested in those because no one knows what they're doing there. Are they saprotrophs? Are they symbiotic with the tree somehow, or what are they doing? And then they form these perithecia and other things on the bark. So then we made analysis, statistical analysis of these things, of the species richness compared to 3 different themes. So we made general linear mixed models of pollarded trees versus unmanaged trees, and to study the difference in tree characteristics, the microhabitat present on the trees. That was one. And then we compared pollarding and tree species versus species richness in one model. And then in the third model, we compared 3 tree characteristics versus species richness. And the combined results of these was that the pollarded trees, they was coarser, even though we tried to find the biggest unmanaged trees we could. The pollarded trees were coarser, they had more cavities, more deadwood, and deeper bark fissures than unmanaged trees. And they usually also had more species on them, especially the non-lichenized fungi. You can see down there to the left. And also in total, the total species richness was actually higher. You see the light gray of the pollarded trees and the dark gray of the unmanaged trees. So there was a difference in species richness, although it wasn't huge, okay? But then when you interpret the 3 models that we made, we find that the highest species richness on the pollarded trees, it was actually more related to the presence of microhabitats that developed with age, right? So there were some unmanaged trees that were really old and had a lot of microhabitats. Okay, So it was more related to that than to pollarding, in fact. So pollarding per se didn't show this result. But the total number of red-listed species was significantly higher on pollarded versus unmanaged trees, yes. But still, 37 out of 49 red-listed species also occurred on unmanaged trees. And the number of species, red-listed species found exclusively on one of the categories of trees was the same, more or less. So, yeah, you wonder what can be the, yeah, no, I can show this first. There was a significant difference in the general species composition of the unmanaged and the managed trees. But, okay, partly overlapping, but there was a difference. So, you can see that the rings are the unmanaged trees and the dots are the managed trees in this detrended correspondence analysis. So, conclusions. What can the conclusions be? That in this environment, where we have big trees high up in the slopes, surrounding with lots of big trees, it would take a lot of effort and money to repollard the old trees. And there is always a risk of them dying, of course, if you do it the wrong way. And the branches are now very thick because it's been a long time. And my conclusion is that the unmanaged trees, they are quite close to the pollarded trees now in species composition and species richness. And probably they can replace the pollarded trees with some time. And my next point is that there are many bigger threats, probably, than the lack of repollarding to this population. And we didn't observe much of the collapse of the trees due to non-management, but we didn't, that was not the main focus, but we could not see a lot of such examples. But then, so this is about repollarding of old trees, but then there's another question of recruiting young trees. Maybe that's more worth it to create microhabitats. So it's a form of veteranization. So I'm not talking about that, but I'm talking about these old trees in this specific environment. And yeah, we have some smaller studies going on. I'm trying to assess what is the mortality of pollarding versus non-pollarding, and how does the epiphyte communities react. So I'm just doing this on one site at the moment, and I did only one resurvey of the area, but after 2 years there was no difference in mortality or epiphyte. But I will try to do it again next year and see what happens. So that's the kind of studies that you need to do, I think, to really see if there is a specific effect of pollarding. But then I want to mention about the threats. And this is the biggest threat to the pollarded and ancient trees, because there are unsustainably high populations of deer on the west coast of Norway. And it's a really big problem because they do this to the trees. In the wintertime, they strip all the bark, they eat it, and they like the elm trees very much because it's nutritious, very nice food for them, it seems. But the trees die, of course. Yeah, you see on the other side of this trunk, underside, they have ignored, they've taken all the bark away. And this tree is clearly dying because you see all the way up to 2 meters that they can stand on their hind legs and really reach, and they love this. but we need wolves, or we need to stop this. It's very difficult to make huge fences around all these areas, so we need to solve this somehow, but it's going very slowly to try to do something about this, unfortunately. So this is the biggest threat, and then of course encroachment by spruce is a problem, and of course the diseases are making problems. But yeah, the ash dieback, Hymenoscyphus pseudoalbidus, is found all over the distribution of the ash trees by now. But the Dutch elm disease is actually still keeping away from the wettest area, it seems, but who knows what's happening with the climate change and so on. But yeah, so I want to just quickly show you some more pictures of the environment there on the west coast of Norway, because I think we need to appreciate, it's possible to appreciate it much more. And it's very nice area. And you can find a lot of these trees still, as I mentioned. There are tens of thousands still. So big ones, nice ones. This is a linden tree. And they're often in the steep slopes ahead, and you kind of wonder how they manage the gravity, because that big trunk is at an angle, and you have the heavy branches, but they're very well rooted, it seems, in this big boulders there. So you would think that this one would tip over, right? But still going strong. And yeah, I think I will stop. Yeah, this one has fallen, but it's resprouting, and this one is in an infield, actually. And yeah, I should thank my colleague Bjorn Norden Lichens, who worked with me in the field at nearly all the sites. And I think I will stop there and maybe take some questions. Okay.
Thanks, Bjorn. It's so good to be able to see some research being done on elms, and such a large number of elms. We seem to have forgotten elms in this part of the world, really. Is there any questions for either for Bjorn or even for Emma? Yes, we have one over the far side.
I'll shout. Which aspects of the tree is the most lichens on? The north, south, east, or west, or does it vary according to the species?
Well, it varies a lot according to the species. I mean, some species are only found at the very base, for instance, and could be all around. But there's often one side, especially in the wetter areas, that is totally dominated by bryophytes, and then on the lee side, or so that there are more lichens. So, yeah, it depends. I mean, it's not really that simple. It also depends on whether water is running, and things like that. So it's a bit complicated architecture.
Any other question? We've got one down here and then one at the back.
Is it fair to say, and the question is really to both of you, you're looking at the opposite side of the equation, because the fungi presumably indicate a deterioration, whereas the lichens, to my understanding, have always indicated robust health.
Yeah, we did look at all these three groups together, and we saw that the fungi increase with age, and so that's right. But I also studied these bark-living fungi, and they don't do any harm to the trees. So it's both decaying fungi and other fungi on the trees. But of course, yes, they tend to increase as more wood is exposed. The number of wood decaying species increase, for sure.
Okay. And we had one last one at the back. You're going to have to run. The gentleman right in the far back, I think. I think it was a gentleman in the back just before him, yeah.
Is that working? Good. Yeah, thank you very much for that fascinating talk. I just wondered, you mentioned how important the microhabitats were in your kind of findings. How did you measure those microhabitats? Was there a certain system you followed, or?
Yeah, well, for instance, one microhabitat that we measured was the depth of the deepest crevices in the bark, and that's actually the best measure of the age of the trees. At least I found that, made a study on oak trees, that's telling much more about the age than the diameter of the trunk. So, yeah, and then that we did by inserting measuring the depth. Then you have to choose the most well-developed part of the trunk. So, so it's the maximum number, yeah. And then we measured the number of centimeters of, square centimeters of exposed wood, and other things like that, and the whole the cavities, of course. Yeah.
Thank you.
Yeah, thank you. I'm afraid we're going to have to move on, I'm afraid. But hold your question. I'm sure there'll be some more time as we go. Bjorn, thank you very much. Okay, we're now going to introduce Oscar Schwentler from Spain, who's going to be working on, or has